Right, good morning. And today should be this always makes, the camera adds 50 pounds. Maybe just eating all that pizza adds 50 pounds. One of the two. But today what we're going to do is our last day of learning how to name things. And we're going to practice. And I hope that today the um, the naming of these things will be very, very straightforward because we're looking at different types of molecules, or we're looking at different types of compounds. We've covered ionic compounds. Okay, we covered those into the ground. We did main group metals, anions, polyatomic anions. We did hydrates. We did transition metals with the parentheses. And today we're going to look at a different type of chemical compound called molecular or covalent compound. Let me write that down for you. Okay. So we're going to be looking at what are called molecular or also covalent compounds. And these are chemical compounds. They're not made up of a metal and a nonmetal or a cation and an anion. For ionic, remember we had like a cation and it had a positive charge and it had or maybe a positive 2 or a positive 3 or whatever, and we had an anion. And these positive and negative charges were held together, so you could only have certain chemical compounds, certain ratios of cations and anions, because the charges had to cancel each other out. Now, of course, some chemicals, some elements rather, could have more than one charge, but we learned about those. But today we're going to learn about this strange world of covalent compounds where things can combine, elements can combine in different ratios. And the reason they can is because these types of chemical compounds, we don't have cations and we don't have anions. We have a situation where they share their electrons. When I say their electrons, I mean the individual atoms in the molecule. They share their electrons, and by doing so, they form chemical bonds. And those chemical bonds um, will how shall I say this? Because of the fact that they're sharing electrons, you can have more than one combination of how these things combine. Because we're not worried about the charges having to balance out. So we're going to have to just remind ourselves, and I hope you have this in your notes, this chart of these prefixes, like 1 is mono, 2 is di. Do you guys have those in the notes? All right. I'm going to erase this because you have them in your notes. But we're going to need to refer to that. So maybe just open your notebook to that page, and if you don't have it, I'll give you a minute if you need to copy it down. And again, when I talk about these compounds, we are talking about 2 or more non-metals combining. 2 or more nonmetals combining to form these molecular compounds. And this is all going to be online again in case you need to watch it or you missed something. So is it okay if I erase this part? All right. You okay if I can? Oh, here it is. Oh. Tomorrow's Friday. Bet you're happy. We'll have our little quiz, have a nice chilled out end of the week. Now, let me see if I can show you some examples. We can talk about different substances, and please notice that carbon is a nonmetal and oxygen is a nonmetal. And I have 2 different versions of how carbon and oxygen can combine with each other. So it's going to be some sort of carbon oxide. You name them kind of the same way as you do ionic, with one respect. The first element keeps its name, doesn't change, and the second element adds the IDE, the ide to it, or changes to ide. So we have to be able to differentiate between these two. I'll show you some others. I could have, for example, NO2, NO, N2O4, N2O. These are all different molecular compounds with different ratios of nitrogens and oxygens. So we need to learn how to name these. But please keep in your mind, nitrogen is a nonmetal and oxygen is a nonmetal. Let's look at some other things, other chemical compounds. I could have PF3. Phosphorus is a nonmetal. Fluoride is a nonmetal. I could have PF5. As a matter of fact, the number of covalent compounds is huge because you have all these different combinations. You can even make some covalent compounds out of one of the noble gases. I told you the noble gases don't normally react, but there is one noble gas that reacts, and that's Xe, xenon. And I could have xenon with some fluorides attached to it. So let's get into the nuts and bolts of how we name these things. And the rules are very simple. We have to use those prefixes to tell us how many elements there are combining. So let me use this as an example, the CO and the CO2. You'd think, boy, these chemical compounds are probably fairly similar. I have carbon, not toxic. I've got oxygen. We need oxygen, right? So what makes these different? What do you think, Dylan? This is a single oxygen, and that has two oxygens, right? So one of these things is extremely poisonous. If you hang around and put yourself in the garage and you accidentally start the lawnmower, you close the doors, what's going to happen to you? And then what'll happen if you're breathing that in? Yeah, someone's going to be looking for a casket. I'm not making light of that. Someday I'll tell you the story about how I got mild carbon monoxide poisoning. That was interesting. And anyway, in that one, where do you find that one? You open your can of Pepsi or the bubbles come out. It's carbonated, carbon dioxide. And this is also a big one too because it's a byproduct of combustion of hydrocarbon fuels, and people get all worked up about climate change and all that stuff. But so that's the one that they blame on all the ills of the world. So how do we name them? You have to tell people how many carbons, how many oxygens. Now the rule is if the first element, C, in this case, if there's only one of them, you don't have to indicate monocarbon. You just call it carbon. So if the first element, if there's only one, you just write the element, carbon. But you have to tell how many of the second element is included. One oxygen. So we call that monoxide. We don't call it monooxide. Because remember I said that the prefix for one was mono or mono? But if our second element begins with a vowel, we drop the vowel on the prefix. Monoxide. Now, on a quiz, if you wrote carbon monoxide, I'm not going to get too worked up about that because you understand the nomenclature. So, carbon monoxide. Now, you tell me, what do you think this one is going to be called? You already know this one, but why don't you tell me what it's going to be called? Carbon dioxide. Yeah. Oops. Because I have two oxygens. So it's pretty easy. You just have to put these. You just have to know what elements are involved and put these prefixes in. Let's take a look at all those crazy nitrogen compounds, and some of them are quite nasty. Some of them are very necessary for physiological processes. So now, here's the trick. Like I said, if the first element, if there's only one of them, we just put nitrogen. We don't have to say mononitrogen, but we do have to say how many oxygens. So what do you think, Wyatt? What are we going to call this one?
Nitrogen dioxide.
Beautiful. This is nitrogen dioxide. a dioxide. Okay. And Maddie, how about this one up here? Hmm? Monoxide, yeah. If that second element is only one, then we have to tell people. Nitrogen monoxide. How about this one? Dylan. Perfect. And see, I told you this stuff's not bad. This is dinitrogen tet tet. We drop the A because oxygen begins with O. Tetroxide. And again, if you write tetroxide, I'm not going to get worked up about that. You understand the process. Now, how about this one up here? Dinitrogen monoxide. You guys have this. You ever, you ever, do you know where this is found? Remember, you're too young, but back in the day, if you went to the dentist to get a cavity filled, they'd put this mask on your face and they would give you something called laughing gas, which would kind of put you in this euphoric state. And you'd be like, pull my teeth, drill my teeth, I don't care. Right? So they would give you laughing gas, dinitrogen monoxide. Do you know where else this is found every day? You can go to the grocery store and find it. Anyone ever buy Ready Whip whipped cream in the can? Right?
That's the air sign.
Yeah. You know, and some unscrupulous people will take that and buy it and go, and they'll inhale the dinitrogen monoxide, and they'll get that woozy feeling. So New York State, People's Republic of New York, they're so strict with their laws. You have to show ID, and you have to be 18 to buy whipped cream in New York. I wish they just secede from the union. This is all going on YouTube, by the way, and I don't take back any of what I say, and I never apologize. So, what happens when you're my age? You just don't care anymore. Now, I will tell you something, though. There are a series of elements that occur in nature that occur as molecules. I may have mentioned them to you. And they are the following. Br2. Bromine in nature occurs as a diatomic element. So it's a Br attached to another Br. And we don't call it dibromine. We just call it bromine. So I'm going to write them all out. And I write them in a certain order so I can remember them. And you can maybe remember them as well. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. These are called diatomic elements. And these are the special cases where we don't say dibromine, diiodine, dinitrogen, for example, because this is the way they come. If you went to buy some oxygen and you could shrink yourself down to the size of the molecule, you'd see two oxygens bonded together. Okay? So, the reason I write it that way is because in my mind, it spells Brinkelhoff. And that's the way I remember it. Right? So in my mind, if I'm thinking, what are those diatomic elements? I just think of like some guy named Mr. Brinkelhoff. Sounds like a little, Christmas elf or something. What's that? Yeah, I'm Herr Brinkelhoff. So you can always remember that. So we don't call those things die. So that's it. That's naming covalent compounds. So what happens? Now let's go from a name to a formula. Let's go from a name to a formula. How about I put carbon tetrabromide? Carbon tetrabromide. What are we going to write for a formula for that? Dylan, you got it. CBR4. Boom, you're done. How about I say dihydrogen monoxide, a very poisonous chemical. Christian.
H2O.
H2O. Right. Now, do you call the stuff in your bottle, hopefully what it is?
I call it oxygen.
You call it dihydrogen monoxide?
I call it oxygen because it's empty.
Oh, it's empty. Okay. Well, then you have to call it air because it's going to be 20% oxygen by 80% nitrogen. A homogeneous mixture, by the way. What do you call it, Carly? Call it water or dihydrogen? Do you go in and say, hey, Danny Mart, how much is this Fiji dihydrogen monoxide? You should. You'd scare the people at the Dandy Mart. You call it water, right? So there are certain covalent compounds that have common names. Now, the way I'm showing you to write these sorts of names, those are there's a big group of chemists called International Union of Pure and Applied Chemists, and they come up with these rules on how to name things. But for common things like H2O, we call it water. We have one called nitrogen trihydride, right? But we don't call it that. NH3 is so common, we just call it ammonia. Ammonia. Everyone's heard of ammonia. You probably buy a solution of it to clean around the house, or if you have litter boxes, if you have cats, that strong pungent smell is ammonia coming up. Maybe if it was used as a coolant of sorts. So water, ammonia, and the other one that has a common name, CH4. We call that, if you call that carbon tetrahydride, well, you wouldn't be incorrect, but we have a common name for that, and that's called methane. Methane. And methane, of course, is you can find that in our fracking industry up here. And along with other types of chemical compounds that contain carbon and hydrogen. But that's for another day because we're going to spend a whole day talking about hydrocarbons and talking a little bit about some of the stuff that goes on in our fracking industry around here, which literally saved the economy of Pennsylvania. So what I'd like to do now is, I think you're ready to just get a sheet and work on some problems because these don't get any easier. And I promise you, reading them, doing them, looking at them, you can get all these. So we're going to do that next, and I'm going to post this on YouTube, and that's it. Hope it helps.